Welcome to Easy Higher Mathematics.
Complement of an element A of a lattice. Its definition is, if there exists an element B belongs to L such that A and B is equal to 0 and A or B is equal to 1. That is, the GLB of A and B is equal to 0 and LUB of A and B is equal to 1. Then B is the complement of A and A is the complement of B. So let us take this example, that is, this is a lattice A and B is equal to, that is GLB of A and B is equal to 0 and LUB of A and B is equal to 1. Also GLB of A and C is equal to 0 and LUB of A and C is equal to 1. Therefore, A is a complement of C and C is a complement of A. Also, B is a complement of A and A is a complement of B. That is, some element may have more than one complement. So, what is the complement of 1? 1 and 0 is equal to 0 because and means GLB least value. So 1 and 0 is equal to 0 and LUB of 0 and 1 is equal to 1. Top value that is equal to 1. Therefore 1 is the complement of 0 and 0 is the complement of 1. That means this lattice, in this lattice every element has at least one complement. So let us go through the next definition. That is, a bounded lattice L is said to be a complemented lattice if every element of L has at least one complement. That is, a previous example is a complemented lattice because every element of L has at least one complement. Now let us go to this theorem. This is one of the theorem in complemented lattice. Prove that in a complement distributive lattice, complement is unique. That means if it is a distributive lattice, that is complement lattice as well as distributive lattice, then every element has unique complement. So in this proof, we assume two complements for a single element A. So that is taken as X and Y. Let X and Y be two complements of a single element A. Finally, we prove X is equal to Y. Since X is a complement of A, we can apply the definition, that is A and X is equal to 0, A or X is equal to 1. This is the definition of complement. Since Y is a complement of A, we have A and Y is equal to 0, A or Y is equal to 0. Now we take this first element, that is X is equal to, this X can be written as X or 0. Comparing to 0, X is the biggest one, or means least upper bound. Therefore 0 and X is the LUB. Now this we can replace this 0 by A and Y because we have A and Y is equal to 0. So we can replace this 0 by A and Y. Already given L is a distributive lattice, then only we can write this is equal to this one. Here we can apply the distributive law. Since L is distributive, then only we can apply the distributive law, that is XOR A and XOR Y. This XOR A can be written as A or X because by the commutative condition, this is A or X and X or Y. But A or X is equal to 1. We have by the definition of complement, this is equal to 1. 1 and X or Y. 1 is the supermost value. So we can get 1 and XY is equal to X or Y only. Therefore X is equal to X or Y. You take this is equation number A. Now the similar idea for y can be written as y or 0. We can replace this r by a and x. Now we can apply the distributive condition y or a and y or x. Y or a can be written as a or y and y or x. A or y is equal to 1 by the definition and y or x. So GLB of 1 and y or x is equal to y or x only. Therefore y equal to y or x. By the commutative condition, y or x can be written as x or y. So this is equation number B. From A and B, x is equal to x or y equal to y or x is equal to y. Finally, we conclude that x is equal to y. Hence, complement of every element of L is unique. That's the theorem.